Hey folks, today we're looking at a multi-tenant RAG system where one vector database serves many customers. Our agent just received a query from tenant A. What are my account policies? The agent must retrieve the right documents without pulling in tenant B's sensitive files. Let's see how it plans to handle this in complete isolation. The planner activates, receiving the high level task. It splits the work. First, extract the tenant's identity from the request, then formulate a search query. Next, apply metadata filters so only tenant A's documents are considered. Then retrieve from the vector database and finally ground the answer. This step by step decomposition ensures we never forget the crucial isolation step. Notice how the planner explicitly includes a filter by tenant ID step. That's our first line of defense against cross tenant leaks. The retriever takes the plan and fires a request to the vector DB. But here's the catch. Our vector database swires documents from all tenants, each annotated with metadata like tenant ID. The retriever includes a metadata filter to only look at documents tagged with tenant A. It also uses semantic search to find the most policy relevant vectors. The result is a candidate set that should be exclusively tenant A's data. The tool router examines the context and decides which downstream tool to call. For retrieval, we need a tool that enforces metadata filters automatically. The router picks our hardened safe vector search tool, which mandates tenant isolation. No generic vector query tool, it's locked down for multi-tenancy. Even with the right tool, we haven't verified the results are truly tenant A's. That's where our guardrails come in. Here's the nightmare scenario. The vector database might return a document indexed under tenant B, but with a similar embedding to tenant A's query. Without a strict metadata check, the agent could feed tenant B's sensitive data into tenant A's answer. The guardrail station detects this. It scans the retrieved document metadata and spots the mismatch. Alarms fire. The tenant ID on this document is tenant B, not tenant A. We caught a potential cross tenant leak just in time. This is exactly why multi tenant RAG needs defense in depth, not just at query time, but every step. The guardrail raises a red flag and sends it to the validator. And the validator now has to make the call, block this document or allow it through. The validator station receives the flagged document. It runs a strict access check. Does the document's tenant ID match the requesting tenant? Absolute rule: if they don't match, the document is blocked. Here, the answer is clear. The document is tenant B's, not tenant A's. The validator slams the gate, blocked. It logs the incident and sends an instruction back to the retriever to exclude this document. Only documents verified as tenant A's can proceed to generation. This approval step is the final safeguard before any text reaches the user. With the block in place, the agent can now safely generate a grounded answer from the clean retrieval set. The system now has a clean, tenant isolated set of documents. The agent assembles the grounded answer using only tenant A's verified policy documents. It produces a concise, accurate response and sends it back to the user. The whole chain planner, retriever, router, guardrail, validator worked in concert to ensure data isolation. The user gets exactly the information they're entitled to, no more, no less. The key takeaway: multi tenant RAG demands isolation at every stage. Metadata filtering, tool hardening, access checks, and validator enforcement all together keep tenant data safe. Never trust retrieval alone. Always verify before generation. Build with the assumption that the vector DB could return anything. Thanks for watching. If you found this helpful, hit subscribe and join us next time for more multi tenant architecture deep dives.